In the last video, we tested the LiteVNA. We originally left an introduction to discuss the impact of T or RVNA port mismatch on amplifier measurements. But the message is more about the performance of LiteVNA 67. This video shows LiteVNA's noise floor by measuring 2.4 GHz and 4.2 GHz cavity filters. We first measure the 2.4 GHz filter. Just as we measured the amplifier earlier, we first turn off the Smith and phase traces that we don't care about. For better dynamics, we need to set a low IF-BU, but too low IF-BU will reduce the scanning speed. We need to balance dynamics and scan speed. Here we use 225 Hz IF-BU, which can achieve 95 dB of dynamics below 3 GHz. Since the 95 dB noise floor exceeds the default display range of the screen, we need to modify the scale. In the Scale menu, we modify the scale to 15 dB per grid, so that a trace noise floor of 105 dB is displayed at the bottom of the screen. Now, let's start testing the 2.4 GHz filter. First, set the center frequency to 2.45 GHz and the sweep span to 1 GHz. This time we used a relatively low-cost ARG1 for to-per cable, as well as a relatively inexpensive SKBC08SF basic mechanical calibration kit. Although it is a low-cost basic calibration kit, we still provide calibration definitions that provide calibration accuracy comparable to economical calibration kits. We still import the calibration definitions from the Microsoft card first. If you are using a low-cost simple calibration device without a calibration definition, you cannot import the calibration coefficient, but use the default value. Now let's go back to the calibration menu, connect the calibration kit in turn and press the button corresponding to the menu to perform calibration. We quickly skip the calibration process and remind you again to tighten the connectors when calibrating, using a torque wrench if necessary. After the calibration is complete, click Done to apply the calibration. At the same time, you can save the calibration in the Save menu that pops up, and you can call it again later. Now we connect the 2.4 GHz cavity filter. Remind again that the connector needs to be tightened. The insertion loss and return loss curves are now displayed on the screen. We can use the filter measurement function of the measurement menu. After turning on the filter measurement function, the filter parameters will be displayed in the upper left corner of the screen. The 2.4 GHz cavity filter measurement demonstration is complete. Through the insertion loss curve of the 2.4 GHz cavity filter, you can see that the effective dynamic of LiteVNA 67 at 225 Hz IF-BU exceeds 90 dB. Now we remove the 2.4 GHz filter and repeat the process similar to the previous one, measuring the 4.2 GHz cavity filter. Reset center frequency 4.2 GHz, sweep span 1 GHz. After modifying the frequency, recalibration is required. Connect the 4.2 GHz filter under test after calibration is completed. Finally, a look at the parameters of the 4.2 GHz filter also verifies that LiteVNA 67 can still provide more than 80 dB of effective dynamics above 3 GHz.